Here's my Lab 2 lines of charge presentation. All right, what is this Lab 2 about? Well, Lab 2 is pretty much the exact same as Lab 1, except for the way we are modeling the charge tapes. So in Lab 1, we modeled the top and bottom tape as singular point charges. But in Lab 2, we are observing these electric forces as lines of charge. So we are treating each tape as a line of multiple point particles. The physical principles at play are the same: Coulomb's law to calculate electric force, as well as Newton's second law to calculate the force of gravity on the top tape, and to substantiate that when the tapes aren't moving, that the net force is equal to 0. I found that there is only one difference between treating the two tapes as point charges and treating them as line charges. The charge required to lift the tape was slightly larger in the Lab 2 line charge model. Here are my data measurements and observations. In Lab 1, we calculated the force of gravity on the tape, the distance of separation, the charge required to lift the tape, 1.3 centimeters, the number of electrons on the surface, the ratio of electrons to atoms on the surface, as well as the length of tape 1, tape 2, and the mass of the two tapes. The observations we made in Lab 1 were the two U-tapes repelled each other, the U-tapes were attracted to the negatively charged pen, and the U-tape was attracted to the neutral object. The reason I'm going over all this is these should be the exact same observations, data, and measurements in Lab 2, except for the charge required to lift the tape a distance of 1.3 centimeters. And this has to do with the way we're modeling the tape. So the charge required to lift the tape in Lab 1 was 6.1 e to the negative 9 coulombs. And the charge required to lift the tape in Lab 2 was around 1.7 e to the negative 8 coulombs, which is a pretty significant difference. And so this new observation is the charge required to lift the other U-tape was smaller in Lab 1. And I will go over this in the next slide. Now, to understand why this is the case, why the charge required to lift the tape is more in this lab, we have to look at this model. So in this model that we made in GlowScript, I made the top tape red and the bottom tape blue. And this is not because they're different charges. They are the same charges, but just to differentiate the two. And so the yellow arrow is the gravitational force on the top tape. The white arrow is the magnitude of the electric force on the top tape. And the green arrows are the electric force on each of the red point particles by the blue point particles. And one assumption that we do have to make in this is that the charge is evenly distributed amongst the point particles. So why is it larger in Lab 2? Why is the charge of the tape larger? This has everything to do with the separation created by this model. So in Lab 1, we only modeled the two tapes as point charges. So there was no X separation. There was only a Y separation. But by treating each part of this tape separately, we are creating more separation. We're including an X separation. And with increased separation, requires a larger charge to lift the tape 1.3 centimeters away. This is the coding that I thought most relevant, the code that I felt was most relevant. These are two for loops. And these two for loops allowed us to calculate each of these green arrows right here. And it also allowed us to create this multiple point charge model. And as you can see, for these green arrows, the ones on the edges tend to point opposite of the blue charges, and this is because same charges repel. And as you go closer to the center, they start getting more and more perpendicular. And I also included this function over here, and that's because we used it in this for loop. And we also use the same function to model the 2-point charges in Lab 1. This is the end of my presentation. Thank you very much.